All right, welcome to eCruz Learning, where it's just that easy with your favorite tutor, Professor Cruz. And today we're going to talk about solving rational equations. All right, now I have 7 different examples. So if you're looking for a specific example, I encourage you to skip and find the problem that you're looking for. If you're new to the topic, I highly recommend you to listen to the entire video. I do not cover word problems in this video. I will leave a link below where you could go and watch the word problems and as well as the little equations. All right, so let's do this. I have 4 steps, and even though there's only 4 steps, because those are the steps that you will always do, there is different approaches to different problems. So that's why I have 7 different examples to make sure I cover everything. So the first step is to find the least common denominator and the exclusions. So the exclusions part might be new to you. So I will explain that. Finding the least common denominator, I will assume that you know how to do that. Multiply the numerator of each term by the least common denominator, or LCD. Then we're going to solve the equation, and then we're going to check that none of the solutions result in a 0 denominator in the original equation, which is an exclusion. Okay, so let's get started. The first problem, example 1. So the first step is to find the least common denominator because I have fractions. So the least common denominator most of the time is just going to be the denominators multiply times each other, or variables that repeat, right? So the least common denominator here for the numbers, the only number that I have in the denominator is 3. And then they both have x, so it's just 3x. Don't make the mistake of multiplying x times 3x and tell me the least common denominator is 3x squared, because then it's not the least, because you're putting a squared in there. X repeats in both, so I only have to write it once. Perfect. So what I'm going to do is that I'm going to multiply everything times 3x. So I'm going to come right here, and I should have left space to multiply the numerator times 3x. That's what the second step is, right? Multiply each numerator times 3x. Basically multiply each term by 3x. So if I do that, I'm solving an equation now. So -9 times, well, the first thing is x's cancel. I hope that you can see that. Let's cancel first. Always cancel first so you work with small numbers. And then -9 times 3 is just -27. There's the equal sign, so I bring it down. In these problems, always keep the equal sign as aligned as possible so that you don't run into trouble. Now, let's cancel things. And that's the reason why I said cancel things, because 3x completely cancels with this 3x, and I'm just left with -5. See, if I would have multiplied first, I will have to get -15, then divide by 3, but I'll still get the -5. Okay, and then 1 times 3x is just 3x, so plus 3x. And voila, I have a 2-step equation that I know how to solve, hopefully. So I'm going to add 5 to both sides. That way that cancels. And I get that -27 plus 2 is plus 5, is -22. And that equals 3x. X is not by itself because it's being multiplied by 3. So I'm going to divide both sides by 3. Okay, and when I do that, I get that x equals -22 over 3, and that's my answer. Now, I skipped a step, I guess, of my own steps, so I'm sorry about that. The first step says find the LCD, the least common denominator, and the exclusions. So when I looked at my original problem, and I'm going to erase this real quick. When I look at my original problem, the denominator cannot be 0. It cannot be 0 because I cannot divide by a number. You cannot divide by 0. So which x value will make these denominators 0? Well, 0. If you set this denominator is equal to 0, if you plug in 0 here, you get 0. If you plug in here 0, you get 0. So therefore, that over here, when I wrote my least common denominator, I should also stated that x cannot equal 0. And the reason I state that is because when I find my solution, I need to check, and that's step 4. I need to check to make sure that x I found is not an extraneous solution, meaning that it's not that number. Because if the answer is x equals 0 down here, then the answer will be does not exist. Okay, it will be D and E. But in this problem, we don't have a problem, if that makes sense, because x does not equal 0, it equals a negative number. All right, so let's move on to example 2. Let's move on to example 2. Don't worry, we have plenty of examples. Now, here's a hint for you. Every time you write these problems, so you don't have to keep rewriting them, leave space after each term because you will have to multiply them by the least common denominator every single time. So I'm going to leave space between them. So let's find the least common denominator in this problem. If I look at the first fraction, that's just x. The second fraction is 10, so I'm going to multiply times 10x. The last fraction is x, but it's already in my least common denominator, so I no longer have to write it. All right, perfect. So now let's multiply every single one by my least common denominator, which is 10x. So times 10x, times 10x, times 10x. And then let's cancel first. But before I cancel, I have to make sure that I write down what x cannot equal. So could you figure it out what x will give me the denominator is equal to 0? You got it. X equals 0. X cannot equal to 0. All right, so here we go. When I simplify, I should not get 0. So these x's cancel, and you get that 10. 10. There's a minus sign, so minus. And then these 10s cancel, and you get 7x left in the numerator, equals, these x's cancel, and negative 1 times 10 is negative 10. And again, I get a two-step equation, sorry. So I'm going to use inverse operations, subtract 10 from both sides. If I do that, I'm going to get that negative 7x equals negative 20. Same sign, add and keep, right? So when I hope that you saw the mistake that I made, because this is just crazy. 10 times 10 is not 10. 10 times 10 is 100. So in reality, I need to subtract 100 from both sides. So this is 100. So this is not really 20. This is negative 110. That's what that is, because same sign, add and keep. So I hope that you were able to catch at some point, wait a minute, 10 times 10 is not 100. Unbelievable. All right. So, and then the last step will be to divide both sides by negative 7. And if I do that, then I'll get that x equals, now a negative divided by negative is a positive, so you need to simplify that, 110 over 7. So that's what x equals. My last step, when I find the x, you guessed it, is to check if it's an extraneous solution. Is it an exclusion? And the answer is no, because that x does not make the denominator 0, so it works perfectly fine. All right, perfect. Let's do example 3. Will example 3 give us an extraneous solution? What do you think? Well, let's do it. Let's see what happens. So, can you tell what the LCD is? Can you tell me what the LCD is just by looking at the problem? That'll be pretty cool. Well, for this problem, there's only one fraction, or one denominator, I should say, because there's two different fractions, but they both have the same denominator. So the least common denominator is x minus 9, which means I'm going to multiply every single one of these times x minus 9. Okay, x minus 9. Now, the cool thing about multiplying by the denominator is that all denominators will cancel because they're all the same. So this is 1 minus, and then here I can distribute. So 6 times x is 6x. Now, be very careful because this is a negative 6. So negative 6 times negative 9 is a positive, and I'm going to put it in red, positive 54. So when you distribute, make sure that you're using that negative sign, okay, every time you distribute. And then these cancel, and you just get 6, okay? Almost a two-step equation, almost, because you have like terms 1 and 54, so we can combine them, right? And we're going to have that negative 6x plus 55 equals 6. And from here, hopefully you're able to solve this. Subtract 55 from both sides. We're going to move right? Move and divide. Move and divide. So this is negative 6x equals 6 minus negative 55 or minus 55 is negative 49 because they're different signs. So subtract the biggest number minus the smaller number and then keep the sign of the higher number and then you'll be exact. And then divide both sides by negative 6. When you do that, you get that x equals, again, a negative divided by negative is a positive. And 6 does not simplify with 49. So that will be the answer. X equals 49 over 6. Is this an extraneous solution? Well, we have to check because we didn't write it at the beginning. So when we look at the original problem, what will make my denominator 0? Well, what will make my denominator 0 is positive 9. And if you're not sure what it is, just grab every factor that you have. In this case, you only have one factor, okay, which is x minus 9. And you're going to set it equal to 0. And then you solve for x. So if I solve for x here, whoa, all right, why not? I'm going to add 9 to both sides, and I'm going to get that x equals positive 9, right? So x cannot equal positive 9. That's the exclusion, right? X cannot equal positive 9 because if it equals positive 9, 9 minus 9 will result in 0. Okay, so if you're able to tell me the number just by looking at it, that's perfect. If not, then this is the procedure. Just set it equal to 0 and solve for it. But this is not that, right? This is not it. So this is still a solution. So x equals 49 over 6. All right, let's look at the next type of problem. So example 4. So this is why there's different examples, because different examples will show you different things. All right, so the first thing here is to find the least common denominator. And the least common denominator in this problem, well, I'll look at the first fraction, and my first denominator is x minus 1. And the second fraction is x plus 3. I just multiplied them. That will be my least common denominator. And right away, right off the bat, I'm going to say that x cannot equal, when I look at the first one, x cannot equal positive 1. And when I look at the second one, x cannot equal negative 3. If you cannot see it just by looking at it, please set them equal to 0 and solve for it. All right, perfect. And now that I have my least common denominator, I'm just going to multiply by my least common denominator, top and bottom. So it looks like I wrote that in the wrong place. So let me write that x cannot equal 1 and negative 3 here so that I have enough space to do the problem. All right, perfect. So let's multiply top and bottom. So just the top, I'm sorry, every term. By x minus 1 and x plus 3 by the least common denominator. And come here, multiply x minus 1 and x plus 3 on both sides. So let's simplify and cancel. X minus 1 cancels with x minus 1. And I'm left with 2x times x plus 3 in the numerator. No more fractions anymore. The equal sign is there. And then over here, I get to cancel x plus 3 with x plus 3. And I'm left with 2x plus 1, which is my numerator, times x minus 1. Okay? Now, I'm going to have to distribute every single, this 2x to every single term inside of the parentheses. So 2x times x is 2x squared when you're multiplying at the exponents. And 2 times 3 is plus 6 and x. There's an equal sign, so equal. Now, I have two binomials that I'm multiplying, so I'm going to use FOIL to multiply these, okay? So 2x times x is 2x squared. And 2x times negative 1 is negative 2x. I'm going to do the same thing with 1. So I distribute 2x, and then I distribute the 1. 1 times x is just plus x, and 1 times negative 1, it will be negative 1. So I result into this quadratic function, but it's really nice because things are going to cancel, right? So what I could do here, every time that I get the same, so I want you to notice that I have the same constant, the same coefficient, I'm sorry, with the same sign. So they will cancel because if I attempt to move negative 2x squared to the left, so my attempt now is to move every single variable to the left of the equation. Okay, that's what I'm going to try to do. So I'm going to subtract here 2x squared, and I'm going to subtract 2x squared. But when I do that, it cancels, and that one cancels as well because it goes to 0. So that's perfect. No longer the square term. Now I'm going to combine the like terms. So I have 6x on the left equals negative 2x plus x is negative 1x minus 1. All right. And then I'm going to add x to both sides. And I'm going to get that plus x and plus x always add with the like term. Notice I did not add it to the 1. That will give me 7x equals negative 1. And which means I'll continue here, which means that I will have to divide both sides by 7. Always divide by the number with the variable. And you get that x equals negative 1 over 7. So that is my answer. And now I have to check that with my exclusions. And my exclusions work perfectly fine. It's not 1 or negative 3. So that is my answer. That's perfect. Let's do example 5. Okay, example 5. So let's look at the least common denominator. For example 5, now I'm going to move a little bit faster because hopefully you're used to it. The only denominator that I have in this problem is x minus 3. They're all x minus 3, which is perfect. All right, I'm going to show you a hack when this happens. Also, we can list our exclusions, and just by looking at it, hopefully you could tell me that x cannot equal positive 3 because that will make every single denominator here go to 0. All right, so the first step is to multiply every single term by x minus 3. But do you really have to? I actually skip this and I don't do it because when I multiply a term by the x minus 3, it will just cancel the x minus 3. So this is just really 6 plus 2 equals 2. Now be careful because 2 doesn't have the x minus 3 as a denominator. So this one will not cancel. This one will be there. Okay, and then at the end, plus 8. Now, this is an advanced technique if you understand that you don't have to multiply every single one by x minus 3 if all the denominators are the same. If you don't understand that, then please follow the step of multiplying every single one by x minus 3, every single term by x minus 3. What happens is that they will cancel. All right, they will cancel when you multiply. The only one that does not cancel is the one that doesn't have the denominator, okay? All right, perfect. So let's combine like terms. 6 plus 2 is just 8. So let's do that. 8 equals, let's distribute. So 2 times x is 2x, and 2 times negative 3 is negative 6. And then we bring down the plus 8. Combine like terms. So negative 6 will combine over there. So this is 2x plus 2. And then I'm going to subtract 2 from both sides. I'm trying to get x by itself. And that will give me 6 equals 2x. And the last step here will be to divide both sides by 2. And when I do that, I get that x equals 3. Hey, I found an answer. Okay, so this is x equals 3. And then I check it against, oh no, my exclusion. My exclusion is x cannot equal 3. And I got x equals 3 as my solution. That means that this does not exist. There is not a number that will make the this original equation a true statement. Okay, so the correct answer is that it does not exist. Why? Because I got the solution x equals 3, but if I plug in x equals 3, it will make the denominator 0, so that does not work. Hopefully that makes sense. Let's move on to the next. We're almost there, guys. Almost there, almost there. Example 6 and then example 7. So let's do example 6. Example 6 talks about 4x, all right, plus 20 over x. So now the denominator has an x in it. Okay, so I just wanted to do a problem like this just to make sure that you get it. There's only one denominator, which is perfect. That means the least common denominator is x, and x cannot equal 0. That's my exclusion because x is by itself. So I'm going to multiply every single term by least common denominator. That's my second step. Multiply everything by x. When I do that, I'm going to get the 4x squared. These cancel. So plus 20 equals 24x. Now, this is similar to a problem that we did before. However, the x squared canceled last time. And right now, I don't have anything to cancel it with, which means this is a quadratic function. I'm going to end up with a trinomial that I'm going to have to most likely factor. All right. So the first step is that I'm going to move that 24x to the other side of the equal sign. So I'm going to have 4x squared. And hopefully you remember, you can always move whatever you want from one side of the other. As long as you do one thing, change the sign. So I just changed my sign of positive 20x to negative 20x because I moved it across the equation sign. And I put it in the middle because I want to factor. But before I factor, remember that if a is not 1, always try to simplify, find a greatest common factor or divide to see if I could simplify, make it work with smaller numbers. And in this case, I can because the greatest common factor here is 4. Every single number here is divisible by 4. So since that is an equation, I can divide every single term by 4 to simplify this equation. And when I do that, the 4's cancel. And I get that x squared minus 24 over 4 is just 6, so 6x. And 20 over 4 is just 5, so plus 5. 0 over 4 is 0. And this will be smaller numbers. Now I can open my two parentheses. If you need help factoring, please check my video about factoring because can we use it? Yes, we can. So they're both negative. And then the only numbers that work here are 5 and 1. And they're both negative, so that's perfect. So 5 and 1. So now the answer to my solution is setting each one of these factors equal to 0 with a zero product property. So because I'm multiplying these two, either x minus 5 equals 0, and then I solve for x, and that gives me positive 5, okay? Or the other, it's true, x minus 1 equals 0, and I solve for x, and I get positive 1. So these are my answers. I solved for x. X is either positive 5 or positive 1. So now I have to do that one thing and check if these are exclusions. But it looks like they're not. The only one that will not make this true is x equals 0. So then these are my answers. Okay, x equals 5 and x equals 1. Let's do one last problem. This is the last exercise, guys. Are you ready for the last exercise? I hope you are. Here we go. Least common denominator. The first step to find the least common denominator. When I look at the first fraction, that will be x. And when I look at the second fraction, it will be x plus 3. So this one I do have to write down and multiply them. X plus 3. Okay. And then I'm going to multiply every single one of them by x times x plus 3. So I'm going to multiply the numerator here, x times x plus 3. Okay, so I'm multiplying. And I'm going to multiply here the same thing, x times x plus 3. I'm going to do my exclusions before I simplify. I have to make sure that x does not equal. So from the first fraction, x cannot equal 0. And from the second fraction, x cannot equal negative 3. Okay, x cannot equal negative 3. So now I'm going to simplify. X cancels with x, and I'm left over here in the top with x minus 3, which is my numerator, times x plus 3. And that equals, now on the second fraction, x plus 3 cancels with x plus 3, and I just get a times x, which is 8x. I'm going to FOIL here. Okay, so I'm going to do a shortcut here. So this is just x squared, okay, minus 9, because that's a difference of squares, and I could just see it right away. 8x, okay, so if you didn't know that, that's okay. You could FOIL and then combine like terms, right? You could combine like terms, but that's not what I want to do. And then I'm going to move the 8x to the other side, just like we did in the previous problem, to write it in standard form. So x squared minus 8x, because I moved it, minus 9 equals 0. Now, nothing else changes, right? Nothing else changes because I didn't move. I only moved the 8x. That's why that's the only sign that changed. And now I can open two parentheses. So I'm going to open two parentheses, set them in equal to 0. Okay, so remember, once you get to this step, if you have a set equal to 0, you have to set equal to 0 if you get a step where you have an x squared. That's the key here. So this is x and x. Can we use it? No, we can't. When it's positive automatically, when it's negative. And I'm looking for multiple factors of 9 that when I subtract them give me negative 8. So that's 1 times 9. And 9 has to be negative, so I could get my negative 8. And then from here, so I don't have more space. I'm just going to write them over here at the bottom. From here, I get that x equals negative 1 or x equals positive 9. That's what makes them 0. So again, just set them equal to 0 like I did in the last problem, and you will be able to see that. Now I need to check these two answers against my exclusions, and it looks like I'm good. It's not 0, it's not negative 3. So those are the answers, all right? If you need to know how to do problems, word problems with this or solve little equations, please look in the description for the next video. Thank you so much, and this is Icarus Learning, because it's just that easy.